Hey guys, welcome back. So in this video, I'll be teaching you how to transmit data from STM32 microcontroller via UART protocol. So let us create a new project, STM32 project. So meanwhile, we'll just go through the manuals you needed for this. So I'm using STM32L4768. So you can use any kind of a microcontroller like F1, like H7, like any kind of microcontroller. It's just generic for every microcontroller. So I'll show you the basic so I'm using nucleo board. So if you are using a discovery board or as a development board, you can download the particular user manual related to it. So that's that. So basically I will be showing like where is the pin out and how can uh, so if you're taking any kind of a microcontroller, come to the section of this development board pinouts, so that when you start doing the UART configuration, it will be easy for you to get out the things up. So here I'm using STM32 L476, yep, RG. Okay, click on next. Write up any random names. I will type up tutorial. Yep, one more manual you can download is like STM32 L4 HAL user manual, so that you can get the libraries necessary for our our API configurations. So this is the manual related to that. Yeah, similarly for your particular board, you can download the same manual. There is much difference between particular modules. So here is that. So let us see whether the configurations is done. Okay, it's yet to be done. So if we are going for the generic driver, we want to see the input output operation. So basically a UART protocol, you will have a write and read, or transmit or receive. So that's that. So here we have transmit IT. This is via interrupt, so that all we will cover later. So first you will do a HAL UART transmit via polling. So that's that. So you can see HAL UART transmit, and give up the UART handle and the data you want to write up, and the size and the timeout. So our project is pretty ready now. Yep. So in the connectivity side, you have like 5 UARTs. Mine is an L4768. So this is like pretty, more. I have more peripherals. So I'm just taking up randomly like UART 1. So I'm keeping up asynchronous because I'm not transmitting any clock signals for the data to be received. So asynchronously I'm doing the transmission on like the TX when the transmission will happen. So that's that. Here you can see A9 and A10 of this L4768 is being selected as UART1. So same, let us verify within the user manual. So you can see I have the development board like L4768 nucleo board. Here we have to search the A9 and A10 pin, and similarly we have to connect it to our USB to TTL module. So we have the A10 as the 33rd pin in the CN10 connector, and A9 pin will be in the 21st pin of the same connector. So here in the UID, CubeID, we can see A10 is the RX. So the RX of the microcontroller should go to the TX of the USB to TTL, and TX of the microcontroller should go to the RX of the USB to TTL. So that's that. So similar way we will be connecting A9 and A10 to the USB to TTL. So that's that there. Let's you know generate the project. Okay, before that, one more configuration. This is something called baud rate. So when you are receiving at the PC side, since we are not using a clock, both has to be at the same baud rate. Here I will be using the default baud rate like 115200 on the PC. Also when I'm using the real term or putty terminal, I will be using the same baud rate. And we know that whenever a UART data byte is getting transmitted, there is a start bit and a stop bit to make sure the protocol works correctly. So that's the way it works. So let's generate the project. Yep. So when you go up, you can see the UART handle as declared as a global. So within the while loop, what we'll be doing, like we will be repetitively printing out, whatever data we want to print out to the UART. So just now, I mean, in the user manual we saw which API to use, that is HAL UART transmit. So here we also saw like what are necessary, like this is the UART handle which we saw as a global, globally declared variable. So that's that. And we need to put up the buffer and the size of the buffer and the timeout. So timeout is nothing but how much time you want to wait till that. So HAL UART transmit. Yeah. So HAL UART, I mean HUART1 is the handle. We have to define the buffer. So I will be using it, I mean buffer with before the while loop, so that in the while loop the data is not getting declared frequently. So even data. So I'll be not be declaring the length. Hello world. Yeah, we just need to give the data buffer. So size, so for now if needed, like we can hard code it. Otherwise the best way is like using the strlen and calculating the data buffer size. So that's that. And the delay we can keep like any between like 100 millisecond, or like based on our data that delay actually varies, but I'm just keeping like HAL max delay. I mean it doesn't matter as of now. Yeah, so that's that. Since we are using strlen, I'm just implicitly declaring the particular pre-directive for it, because I don't like this warnings to come up all the time. So yeah, string.h. So that's that. I have already connected the microcontroller to my PC. Now I'm going to build the program. I hope no errors are there. Yep, no errors are there. Pretty good. Okay, one warning is that now just flash the program. Okay, click on the debug configurations as default. Okay, and one more thing, we can put up a delay such that the printouts coming on our terminals will be reading out correctly. So that's that. Now I have connected our COM port. Now you can see COM port 5 is already connected. Yep. So we'll open up the realtor. So similar way you can see your particular USB TTL's COM ports, I mean whatever it is coming on your PC. So similarly select the particular COM port on your PC, select, I mean set the baud rate as you have set up in the GUI configurations. Do the open. You can see the hello world is getting printed so fast. So that's that. Thank you guys for watching up the video.